class, this is Gigi from Kauai Community College. This is a derivative problem that has to do with the quotient rule. So, how do we know this is a quotient rule? First of all, we look at the structure of this function, and there is a division problem. So we know there is a quotient, right? But do we really want a quotient with a polynomial on top, and then there's a product right here on the denominator? Do we really want that? And in this case, we say, I don't think so. I do not want to apply quotient where there is also a product. So we are going to go ahead and rewrite this as y is equal to x squared minus 5x plus 6, all divided by x squared minus 1, because that's what it is when we multiply that out. And that is a lot nicer than having a product down there. Okay, so really think about it and actually use your common sense and clean that up before you actually apply the quotient plus product in there at the same time. That sounds messy, right? So the quotient rule say that if you have a function divided by a function, say f of x divided by g of x, and you are taking the derivative of it, that will equal to, and I always write g of x on the denominator square, and then on the numerator is a subtraction problem, and it is derivative first times the second, derivative of the second times the first, kind of like the product rule except for its subtraction. Okay, so that is the quotient rule that we are going to apply here. So we will see that dy, which is the derivative of y with respect to x, is going to be, on the denominator, I will have x squared minus 1 squared. That's the g of x squared. On the numerator, I would have the derivative of the top, which would be 2x minus 5 multiplied by the bottom, which is x squared minus 1. Okay, so that would be the derivative of f times g minus the derivative of g times f on the numerator. So I'm going to go ahead and extend my fraction here. And then I will have minus the derivative of the bottom would be just 2x multiplied by the top, and that would be x squared minus 5x plus 6. Okay, now what do you do after that? You distribute and you clean up. Okay, so when we distribute, the denominator will stay the same, which would be x squared minus 1 squared. The numerator would be 2x times x squared is 2x to the third minus 2x minus 5x squared plus 5. On the denominator, we will distribute the negative 2x into each one of those. So that would be negative 2x to the third. Negative times a negative is a positive 10x squared. Negative times a positive is a negative. 2x times 6 is 12x. Then we get to clean up one more time. And so that would be equal to dy dx is equal to, denominator is still x squared minus 1 squared. Numerator, oh how nice, 2x to the third, 2x to the third. And then negative 5x squared, positive 10x squared. We'll have 5x squared left, minus 12x minus 2x is negative 14x, and then the plus 5. Okay, the question is, can we factor out any further? Maybe, maybe not. Let's see. If we try to factor, we will have 5x, and then we'll have x. That is a -5, so that better be negative, positive, and +5, so that would be negative and negative to make a negative in the middle. So I'm gonna have -5 minus 1. No, that's not gonna work, right? And then if I have -5 right here, and then 1 right here, that's still not gonna work, so it's not factorable, and I will just live with this as my answer. But if you can factor and reduce, then do so.